Welcome once again to Electcom Automation. Today we are going to learn basic electrical installation. So these are the components and appliances that we are going to use and that we are going to control. So the question might always arise is from design a building installation using one D4 distribution box, 4 lamps, 1 residual current circuit breaker, and 1 changeover with 1 double 13 amp socket and 3 gang switch. And each of the circuit in the distribution box should be assigned to each of the lamps. That is to say that each circuit carries only 1 lamp and 1 circuit carries the socket. Now, this is the solution. This can also be applied to all other building electrical installations and wiring. So let's start it together from the scratch. I'm going to explain each of the appliances and the components that is here one after the other. So follow me and pay attention attentively. This is my distribution box, D4 single phase distribution box. Why is it called D4 single phase distribution box? Is that it contains 4 miniature circuit breaker and it is single phase. It is being powered with single phase, so that is the reason why it is called single phase distribution box. And it has a main breaker, which is this. So this main breaker is what is used to control all the circuits that is inside the panel. So that therefore means that if I turn off the main breaker, it's going to trip off all the circuit breaker that is here. So let's do that before we go again. Now I can drop here. You see all the circuits have been turned off. So that's not what we are going to do. Let's just follow it step by step. Now you also notice that each of the circuit is assigned to each of the appliances. I'm going to show you how the wiring is being done, but let's follow this step first. So if I trip down this phase breaker, therefore means that there's a particular circuit that is going to trip off. So let's see that. All right, therefore means that this circuit is connected to this lamp. So if I take that one on, let's check another circuit. This is another circuit. So it therefore means that this 2 bulb is connected to this one circuit in the distribution box. So I'm going to take that one on back again. Let me take this one. So it therefore means that this circuit here is connected to this particular load, which is this lamp here. So I'm going to take that one on and take this one. So it therefore also means that the socket, the 13 amp double socket, is to this breaker here in the distribution box. Therefore this is the load to this circuit. So I'm going to take it on again. Now let's go to the main explanation now. So this is my changeover and this is the residual current circuit breaker. So let's follow it step by step, the breakdown, how voltage take in and how it is get to the load from the distribution box. Now this is a changeover and this is a supply from NEPA. So this is a changeover. So how do we wire a changeover? The changeover have 2 inputs and 1 output. Therefore means that 1 input will be assigned to a generator and 1 input will be assigned to NEPA supply. Now in this case, I'm using a NEPA supply. So this is the cable that I'm using as my NEPA supply cable, and this is the changeover. So now let me open and show you the inside of the changeover and how it look like. And I'm going to show you the wiring diagram as well. All right, so now as you can see from here, these are terminal input of a changeover and this side is for generator. So before we can be able to access the NEPA side, we need to drop the NEPA down so as to remove the voltage from that part. So I'm going to take it down. All right, so this is the input from the NEPA. So therefore means that if you connect these two terminals here, your live and your neutral, you are going to get the input from the NEPA. So this way is being terminated, and this is the input from generator. The downside is always the input from the generator, and this is where our load is. So I'm going to show you. All right, so that is our load. Now let's see how many volts is entering the changeover and how many volts is leaving the changeover to our house load. So I'm going to use my meter. This is my multimeter. So I'm going to turn it to 750 AC volts. So that is the maximum voltage here for me. All right, so let's do the measurement. Now this is my meter. So I'm going to put one test lead here and another one here. All right, that is the measurement. We have 205 volts. All right, now you notice that if you test the output load, you will not get any result. The reason is that the changeover is at neutral position, neither getting the supply from generator nor getting the supply from NEPA. So it's only when you take it up, that is when you are going to get the supply voltage from the NEPA, and you automatically going to give you an load voltage from the output of the changeover. Now let's see how that works. All right, that is it. So now let's test the output now and see the output voltage from the NEPA supply to the changeover. All right, so we are going to test the output from the changeover. So this is the output of the changeover. All right, so I'll put the test group, and we are still getting 205 volts. All right, so therefore means that our changeover is very active and it's working very well. Now let's see the input from the residual current circuit breaker. So this is the input from the residual current circuit breaker. It's still giving us 205 volts, and this is the output from residual current circuit breaker. So before that, let me show you how the connection is being made to the residual current circuit breaker. Now, as you can see, this is the input to the changeover and this is the output to the changeover. So the output to the changeover enters the input of the residual current circuit breaker. So the upside is the input of the residual current circuit breaker. So you can even test to know the direction in which the current flow. So we are going to use our tester. This is my tester. All right, here is the direction of current flow. It's flow from here down here. So now this is the output of the residual current circuit breaker. So the output of the residual current circuit breaker enters the distribution box. Therefore also means that at this point, if the residual current circuit breaker is kept at off position, therefore means that there will be no supply to the distribution box, but they will be supplied to the changeover, because the changeover that give out the supply to the residual current circuit breaker. So let's see that. All right, you see, as I trip off the residual current circuit breaker, there is no supply to the distribution box. So I'm going to take that on again. Now let's get to the distribution box. Now you see the distribution box contains of 4 mini actual circuit breaker, and this breaker is assigned to each of the circuit that is here. So we have 4 circuit, and this is one circuit, this is one circuit, this is one circuit, and that is 3 circuit, and this socket is another circuit, and that is 4 circuit. This switch is used to control each of the circuit of the lamp. So this is the phase lamp, and these two make up one lamp is attached to one circuit, and this one is one. So therefore means that if we use here, we are going to control the switch, the bulb that is here. Now each of the breaker is also assigned to each of the units here. So this one is assigned to the socket. So if you take it, you see the socket is off. I'm going to power it on again. So if you take this one down, you have to take this circuit off. So I'm going to power it up again. If you take this one down, you have take this circuit off here and still going to power it again. If I take this one, you have take this circuit off here and still going to power it again. So in our next video, I'm going to explain how to rate your circuit breaker. Don't just pick 20 amps, 25 amps, 15 amps. So for the purpose of protection. So I'm going to show you that. So now I'm going to show you how the connection of the lamp and the switches is being done. Now this is a switch. This is my switch and this is my lamp.